Have you ever wondered how a computer program makes decisions or repeats certain tasks? Well, the secret lies in control transfer and conditional action instructions. These are the unsung heroes of programming and assembly language, quietly directing the flow of execution in a program based on specific conditions. Control transfer instructions are the traffic cops of coding. They direct the flow of execution, transferring it unconditionally or based on certain conditions to specific addresses. Think of these as the decision makers, the ones that say, "Okay, where do we go from here?" Some common types include the unconditional jump, conditional jump, call, return, and interrupt. Each has its own role and function in the grand scheme of program execution. On the other hand, conditional action instructions are the evaluators. They compare, assess, and jump based on the results. They're the ones asking, is this true or false? Is this greater or less? And then deciding what to do next. Some of these include compare, jump if above or below, jump if greater or less, loop, jump if carry or no carry, and jump if overflow or no overflow. These instructions are like the DNA of a program, fundamental building blocks that allow it to function and adapt. They enable the creation of control structures like loops, conditionals, and function calls. They're the reason why a program can execute specific blocks of code based on certain conditions. However, it's important to note that the specific syntax and available instructions can vary. This depends on the architecture and assembly language used. It's like cooking. The basic method might be the same, but the ingredients and techniques can differ based on the cuisine. So there you have it, a brief overview of control transfer and conditional action instructions. These little pieces of coded instruction are integral to programming, acting as the brain behind a program's ability to make decisions and repeat tasks. Now that we have a basic understanding, let's delve into the specifics of control transfer instructions. Control transfer instructions are the backbone of decision-making in programming. But what do they entail? Let's unpack this, starting with the unconditional jump, or JMP for short. This instruction transfers control unconditionally to a specified address. Imagine it as a leap of faith into a new part of your code, without any conditions holding you back. In assembly language, you'd simply write it as JMP target_label, where target_label is your desired destination. Now, let's add a twist. What if you want to jump only under certain conditions? That's where conditional jump comes in. These are instructions like JZ, JNZ, JE, JN, and so on. They transfer control based on a specified condition, such as whether a value is 0, not 0, equal, or not equal. So in assembly, you might write JZ target_label, which would mean jump to target_label if 0. Next up is the call, or call. This instruction is like making a phone call to a subroutine. It pushes the return address onto the stack and transfers control to the specified address. So you'd write call subroutine_label in assembly to call upon a subroutine and get things done. After the call, of course, you need to return. That's what the return instruction, RET, does. It's like hanging up the phone after a call. It pops the return address from the stack and returns control to the calling routine. In assembly, you'd simply write RET to signify this. Lastly, we have the interrupt, or INT. This instruction triggers a software interrupt, transferring control to an interrupt service routine. Think of it as an emergency button, diverting control when certain conditions are met. In assembly, you'd write INT interrupt_number to activate the desired interrupt. Understanding these instructions is key in manipulating the flow of a program. Now, let's move on to conditional action instructions. Conditional action instructions are another crucial aspect of programming. But how do they work? Well, let's dive right in. First up, we have the compare instruction, or CMP. This function compares two operands and sets flags based on the result. It's often used before conditional jumps. For instance, in assembly, you might see something like CMP AX, BX, which compares the values of AX and BX. Next, we have the jump if above and jump if below or equal instructions, denoted as JA and JBE respectively. These instructions jump if the first operand is above or below or equal to the second operand, and they're used in unsigned comparisons. For example, JA target_label would jump to the target label if the first operand is above the second. On a similar note, we have jump if greater and jump if less or equal instructions, or JG and JLE. These are like the previous instructions, but they're used in signed comparisons. JG target_label, for example, would jump to the target label if the first operand is greater than the second. Then there's the loop instruction, loop. This function decrements the loop counter and jumps to a specified label until the counter reaches 0. In assembly, you might see something like movcx5, followed by a label and a loop instruction, which repeats the code until the counter is 0. Moving along, we have jump if carry and jump if no carry instructions, JC and JNC. These instructions jump if there's a carry or no carry after an operation. JC target underscore label, for instance, would jump to the target label if there's a carry. Finally, we have jump if overflow and jump if no overflow instructions, JO and JNO. These instructions jump if there's an overflow or no overflow after an operation. An example would be JO target underscore label, which would jump to the target label if there's an overflow. So, as you can see, these instructions give us a lot of control over the flow of a program. They allow a program to take action based on specific conditions, which can be incredibly useful in a variety of applications. For instance, you might use a loop instruction to repeat a block of code a certain number of times, or a jump instruction to skip over a block of code based on a certain condition. These conditional action instructions are foundational in building control structures like loops, conditionals, and function calls. The specific syntax and available instructions can vary depending on the architecture and assembly language used, but the underlying principles remain the same. These instructions allow a program to take action based on specific conditions, making them incredibly useful in a variety of applications. Let's wrap up with a summary. So far, we've delved deep into the world of control transfer and conditional action instructions. We've unpacked their importance in programming and assembly language, and how they allow us to control the flow of execution in a program based on certain conditions. Let's quickly recap the key points. We began with control transfer instructions, starting with the unconditional jump, which transfers control unconditionally to a specified address. We saw how conditional jumps, like JZ or JE, transfer control based on specified conditions like 0, equal, and more. We also touched on the call instruction, which calls a subroutine, and the return instruction, which hands back control from a subroutine to the calling routine. Lastly, we discussed the interrupt instruction, which triggers a software interrupt, transferring control to an interrupt service routine. Next, we explored conditional action instructions. We began with the compare instruction, which compares two operands and sets flags based on the result. We then looked at various jump instructions like jump if above, jump if below or equal, jump if greater, and jump if less or equal, which transfer control based on the comparison of two operands. We also discussed the loop instruction, which decrements a loop counter and repeats a task until the counter hits 0. Finally, we delved into instructions like jump if carry and jump if overflow, which jump based on the occurrence of a carry or an overflow after an operation. These instructions are foundational for building control structures like loops, conditionals, and function calls. Remember, the specific syntax and available instructions may vary depending on the architecture and assembly language used, but the principles remain the same, giving us the power to make our programs make decisions, repeat tasks, and respond to different conditions. With these instructions at your disposal, you can now control the flow of any program, making it respond to conditions and repeat tasks as needed. Thanks for tuning in, and keep exploring the fascinating world of programming.